So in this video, we're going to cover bar charts plus error bars. Sometimes people call them error bar charts, but I think the important thing is to get that they are bar charts that show you error. You can make bar charts without error, but that's just silly. So I have several videos on Ggplot. If you're brand new to Ggplot, you might consider watching them somewhat in order. So histograms, uh, scatter plots, box plots, and now we're moving on to bar charts. So I'm going to show you how to make a bar chart in Ggplot, a couple different types of bar charts, and then the next video will cover line graphs. And so let's start with talking about what is a bar chart. So bar charts are normally going to show you the mean, whereas box plots are normally used to show you the median. That's not a hard and fast case, but generally the case. The error bar part of it sticks out like a whisker. But what the error bar does is it tells you the precision of the mean. So really focusing in at least this statistics-based course on models and how we represent our data. So we use some sort of model. Generally that model is the mean for categorical group type data. And so if the mean score is 10, you want to know how good is that model. Well, I can use my standard deviation or my standard error to tell you how good the model is. And so very wide variances don't give you much faith in that model because it says it's a lot of variability, but here's one score. Whereas very small variances give you a lot more faith that that model's correct. Okay? And this is in a very traditional statistics sense in the idea that participant scores are the model plus some error. So you want error to be small. Okay? And so we can display that on our graphs to show people in a visual way how believable the scores should be. So error bars are normally one of three types: confidence intervals, and that's usually 95% because we liked to set alpha, type 1 error is 5%, or the standard deviation or the standard error of the mean. All three of those I feel like are pretty equally common depending on researcher preference. What I'm going to show you how to do today is actually the confidence interval version. Okay. So some data from the Andy Field book with one independent variable, meaning one X variable. And so there's some data called the chick flick data where we have 20 men and 20 women. So that's one independent variable. Half of them saw a chick flick, Bridget Jones' Diary. Half of them saw a control movie, which is Memento, which I think is a great control movie, but maybe not in this example. So that's another independent variable. And then we measure their physiological arousal, how much they enjoy the film. So this could be GSR, so the hand sweating. It could just be, I really was excited about this movie. So we have a measure of enjoyment of the film. So one important thing is to make sure that your categorical variables are factors, or you'll either get an error in Ggplot, or better yet, it'll try to make you a continuous graph. And it doesn't really like to do these things. So always set your categorical variables as factors first. And that's actually a good general life rule because that will help you remember what your data is later when you come back to it. So let's start by loading that chick flick data and then setting our variables as factors. So I don't think I've used that data set yet. No, not quite yet. Okay. So let's do that. Alright, so first thing I'm going to do is load the data set. So call it chick. So I'm going to use the read.csv function. And I have it saved in my working directory. So I can just type it in. All one word. I can type today. So I could look at the files here in this working directory, which it should have gone to. Okay, well, it doesn't actually show you the working directory, but I could click through, but I know that's how it's spelled. Okay. So that should let me read in the chick flick data, and it does. Okay, so here's the first problem. That data set does not have gender and film coded as a factor variable. So if I took a summary of it, it's actually going to treat gender and film as continuous variables, or at least integers, which is what they're listed as over here. And that's no good. So our first thing I want to do is set them to actual factors. So I'm going to take chick gender. I'm going to set that equal to a factored version of it. So let's factor out the columns. So chick gender again, because I wanted to factor one column. My levels are equal to 1 and 2. My labels are equal to, what order is it in? Men and women. And so here, let me do this so you can see everything at once. So remember, the factor function works as if you have a column of data here. You tell it what the levels are. Remember, the concatenate function binds them together. You have to have that. And then the what are the labels for those levels? So let's run that. Now you'll see that gender over here is a factored variable. I'm going to do the exact same thing for the film variable. Don't judge my typing. So column of data, chick film, and then the levels. So if you have more levels, add more numbers here, and then the labels. Bridget Jones, Chick Jones, and Memento. All right, so that now gave me 2 factored variables, which is super important for the next part, where we're going to create a plot. So let's create a plot. So to plot mean scores, you have 2 options. You either have to have the means already calculated, or you can do it on the fly in Ggplot. And I like to not remember that I have to do something else first, if at all possible. So I'm going to show you how to calculate them through Ggplot. If you've already calculated them through tapply, the code is a lot shorter, but I think it's probably a little easier to just do it all through the plot with the giant data set. Okay, but you can calculate directly from means as well. So the first thing we have to do is set up our blank plot. And so that blank plot we'll get by using the same Ggplot code we've been using in all these videos. So let's do chick box. Oh, no, sorry, this is a bar chart. So Ggplot, which is the code to create me a blank graph. And it's dataset name, and then AES for aesthetic, X variable first. So let's do the film one. Then your Y variable, and that's arousal. So we got X always comes first, and then Y. So that's arousal. So that should have created me a blank plot. Let me show you. And it's like, okay, that's great. Add some layers to your plot. So here's the complicated part. The function to create a summary variable, or the means, is called stat summary. Now, stat summary is not inherently difficult. It's just it's a little different from using the geom bar, geom points, or geom histogram functions. And so I'm gonna walk you through what all of that other stuff does by typing it out here. So let's create our plot. So we got chick bar plus. Now we're going to use the stat summary function. Okay. And stat summary allows you to create your summary statistics on the fly. So it's a statistical summary, which the name comes from. So the first code I'm going to use is fun.y. So fun.y is the function of y. What function should I calculate on the y variable? And I want the mean. So give me the average score. Now, other thing I'm going to do is do geom. I want a bar chart, so I'm going to put bar here. I could make points. I could make a histogram. It would be a little weird, but there are lots of options here for geom. But let's go bar chart because we're making bar charts. And that's technically all you need, but so let's just do that real quick. So it gave me some bar charts. Cool. Now, if I didn't want the bar charts to be black and white, what I could do is use fill. Okay, the fill option, and this is super important, the fill option is what color of the bar. So let's make that white. And color is the color of the lines around the bar. I'm going to make that black. It could make it green and purple, but let's go black and white. So now I have a black and white set of bars. If you are sort of unfamiliar with the difference between fill and color, I tell you to watch, keep watching, but also watch the Scatterplot video. I talk a lot about fill and color, but if you can remember that fill is anything that fills in like bars or confidence interval bands, and color is like the outline of it. That'll help you keep this straight. Because that'll be important here in a second when we do multi-size, multiple variables on your graph. All right, so that's how I create the basic bar chart. Now to add the error bar part, it's another stat summary function. It's a different one, so you do have to add a second one because this is a second layer. And we're going to type this out. There are several ways to do error bars. This is just one of them. There are more than several actually, but this is, to me, the easiest one if you don't already have the data calculated. So let's do stat summary. Now, let's do one piece here at a time. So it's function of the data. So what function do I want to calculate on the data? And the function for confidence intervals is mean CL normal. You can also do boot. But you just type in mean CL normal, no open and close parentheses. And then our geom type, what type of geometrical object we want to add, is error bar. So be sure this first one is bar, because I want to add the bars here, and the second one is error bar. So let's try running just that. And you'll see why this is a crazy idea. Okay. So it does create you some error bars, but those error bars look a little nutty because they're the full length of the bar. So let's see if we can fix that. Okay. And what function does that is actually this width function. So let's do width first. Width of the bars, I want to be 0.2, just to make one up. And that looks a little better. Okay. If you want them to be wider, make them wider. If you want them to be tiny, make them tiny. Let's do 0.02. They're gonna look nuts, but we can do it. And now they're very small. So you can change that to just whatever you find aesthetically pleasing. Okay. Now there's one more piece that I have in my notes on PowerPoint here, and it's this position dodge function. Okay. What position dodge does is it forces things to not overlap. And so the position dodge function makes sure that two bars aren't on top of each other. I don't know that it's super necessary in an error bar sense because you do want it to be on top of it, but you might need that code. And we're going to use that code again in a minute. So we could say position equals dodge. You can also control the exact width of the dodge here, 90%. But in this particular case, if I just did position equals dodge, it's not going to do a whole lot to my plot. So you might play around with that code a little bit, and again, if you're not sure what something is doing, just take it out and add it in until you see what you like here. Okay, so that is all stat summary requirements for the mean, and then here are the ones we typed for confidence intervals. And then let's clean up this graph. So I'm going to use my cleanup code. And so what that is, since this is a new video, is I have a set of code here, this piece, oops, that cleans up my graphs. So I've saved it all as cleanup because it's much easier than cutting and pasting it 1,000 times. And what that does is it's going to turn off all the backgrounds. So panel grid major turns off the major grid lines, minor turns off the minor ones, background turns off the background. So this is essentially getting rid of all that gray stuff. And then I'm going to add an axis line. I found that by Googling how to turn off the ugly gray background in Ggplot. Lovely tutorials online. And so I have all of that saved as a specific name. So I can then just use it down here without having to type the whole thing again. So let's do that. Now that graph is much cleaner. It's very pretty. This is more traditional of what we might publish in a journal, but I haven't fixed my X and Y-axis labels. So I'm going to add an X lab, movie watched by participants, and a Y lab for Y label, arousal level. And then if I wanted to, I could also change the X-axis labels. I think they're pretty good right now, but if I wanted to, I could change it. So scale X discrete will allow you to change the labels. And it's labels, oops, equals, let's say, girl film. Not really, I like Memento better, but guy film. Talk about stereotypes here. Now let's try all of that. And so I have control, using scale X discrete, I have control over these here. Now remember, if you put 2 codes here and they're actually 4, it will lock them off. So be sure you have the same number of labels here as you do little mini label things down here. If X is continuous, you use scale X continuous. And that actually is a function that controls the way the scale looks, but labels is clearly part of the way it looks. So it's an easy way to change the individual labels. Okay. You could also change them by refactoring your variable with appropriate labels, whichever way you find easier. Now that looks like just like a lot of code to make one graph, but that's because we haven't pre-calculated the mean and the confidence interval. And I think it's a little easier because when I'm working with big data sets, sure, I've calculated the mean and the confidence interval doing whatever analysis I might have been using, like ANOVA, but often that actually just shows you the confidence interval of the difference between scores, so you're kind of stuck, and this way it's easier just to take your whole data set and create a graph and not have to first calculate a bunch of summary statistics. Okay, so let's try now. So here's our pretty chart. We just made this one. 2 independent variables. And so let's say you wanted to have a factorial design. And so I'm really talking about ANOVA because it's generally what the kind of graph you're going to make for ANOVA or t-test. Well, you might also do this for repeated measures, but I'm really going to talk about how to handle repeated measures in the next video with line graphs. But just a fair warning that if you want to do bar charts with repeated measures, you certainly can, but your data has to be in long format. If you don't know what that particular thing is, there's a video on the reshape function, a couple videos back that you should watch on how to melt and cast your data from long to wide format. I'm sorry, wide to long generally. So you can make repeated measures bar charts using Ggplot. You just have to be sure your data is in long format. That being said, let's do all between subjects to start. So let me go back. So this is the code we're going to talk about. Let me break it down for you. So this is 2 independent variables. Okay. And notice I'm not labeling this as between subjects or repeated measures. This is 1 independent variable and 2 independent variables because they are created in the exact same way. It's just the data set has to be in long format. So let's make our second bar chart here. So Ggplot, I've got my data set name is chick. Okay, so be sure you're naming this and this different things. So don't overwrite your data set as a plot. Now I've got my aesthetic. I've got my first X variable, which we did as film. My DV, my Y variable, arousal. And then let's do fill equals gender. Okay, so the fill function, remember, controls the color of the bar. The other thing you can do right here is just say, I'm also going to color by gender. So at the moment, we don't actually have anything to color because we're not creating confidence interval bands or anything. But remember that fill controls the color of the bar, color controls the outline of the bar, And if you want to talk about how fill and color can work together, go back and watch the scatter plot video because it talked how to use those two things and what they really do in plots that use both a lot. I'm just going to do fill equals gender right here, but if you aren't sure, try both. It doesn't hurt you because I'm not going to have a specific color variable. Okay. All right, so let's take that chick bar. I'll show you. It's a blank plot. Okay. Now let's add stuff to it. So we're going to use that stat summary function again. So what's the first one? Well, the first thing is function of y equals mean. Okay. And then I'm going to add a geometric object, the bar graph. And then I'm going to not do something real quick, just to show you what will happen if you don't do the next line. So let me run this. Oops, I forgot to run my first line. How funny. All right, that should make us a bar graph. All right, so I didn't use color and fill up here like I did. So down a little bit. So here I used fill and color to control the colors of the bars. However, I'm not going to do that on this particular one because I have two of them at once. And so I'm not going to do that right now. Instead, I left off the position function. Okay, so if you do not include this position function, oops, and tell it to dodge, like dodgeball, it's going to put them on top of each other. Okay, so that position dodge function will stack them next to each other. So that's what you want to use position dodge for. Now with error bars, doesn't seem to do anything, but position dodge is really to make sure the bars don't overlap each other. So now let's try stat summary, oops, and let's do the error bars. So function of the data equals mean CL normal. Okay. The geom type this time is error bar. And we can do position equals dodge and a width function to control the width of the bars. Okay. So let's try both of those. Okay. So now you'll see where position equals dodge comes into play. And so I have my my error bars look not so bonkers. So let's take this line out and see what that does. Now they look really bad. And so this is where that other piece of code comes in that we were talking about a minute ago. I said it doesn't always seem to work. Well, that's because it's really designed more for this situation where we have stacked graphs. So this is a good way to learn exactly what each piece of code does, is taking it out and putting it in and seeing kind of what happens. So here is the piece here. Position equals position dodge, so it's actually a function too, and tell it how much to dodge. Okay. 90% seems like a good option. And so that, oops, I'm sorry, that should be a comma. It's all part of stat summary. I got excited. Should give us the error bars in the right place. Okay. And I found that particular piece of code by Googling it as well. Like, whoa, error bars, what are you doing? And so when you have only one independent variable, position dodge doesn't do just a whole lot. But when you have two independent variables, it's pretty important. Otherwise, your error bars look a little drunk. So now let's add X and Y axis labels. So film watched. Right. Y lab. Arousal level. Make the chart even prettier. All right, so now my chart has appropriate X and Y axis labels. And so I could start to clean up the graph. So let's add our cleanup function and run that. So now the graph looks even better, but issue really now is this legend label. And so what I'm going to do is show you scale, fill, because we're working with the fill of the bars. And so I want to change what fill they have, which will also allow me to change the label that it's associated with that fill. And I'm going to use Mangle because that gives me more control. Okay. So scale fill Mangle is going to change the fill of the bars. I could actually use scale color Mangle, I think, to change the line around the bars. But I don't know that I want to get that particular. So with scale fill, what I can change is the name. So I can make it more descriptive. And that will change the name of the gender out here and allow me to make that journal appropriate. And then I can also change the labels. I don't have to, but I could. I could make it boys and girls, which will allow me to change them if they're not capitalized or something. But the important one that you have to have when you use the Mangle function is values. And so that'll allow me to change the colors. Let's make them black and white to see how silly that'll look, but that'll change the colors of these bars out here. There are only two because there's men and women here. Okay, so let's run all of that. Oops, make sure you get this highlighted. Okay. So white's not going to work, clearly, but I could make it gray. And there are lots of options. You could do gray 10, gray 50, and I would Google Ggplot color names, and I'll give you a big list of them with a color swatch next to it. And that looks a little more appropriate. Okay. So that will allow me, the fill Mangle allows me to control every single part of the legend. There's lots scale fill brewer, scale fill, lots of different scale fill options, which you can see if you just start typing it in Ugly Studio. So there are a bunch of different ways to do this. I like Mangle because it gave me the most control, but you could find a couple of other options if you start to Google how to change the fill of the variables. Will probably get you there a little faster than how to change the legend, but that is what it will allow you to do as well. Okay. So all in all, this is how you make error bar charts. So how to get it to give you the mean, the 95% confidence interval, and then how to clean up those graphs and change the labels for the different pieces.